Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In electrophilic aromatic substitution, EAS, substituents are classified by two independent properties, 1. Whether they activate or deactivate the ring toward EAS, and 2. Whether they direct incoming electrophiles to ortho, para or meta positions. Key principle: most deactivating groups are meta-directors because they withdraw electron density from the ring via resonance and or induction. However, halogens are a classic exception. They are deactivating, electron withdrawing by induction, yet ortho-para directing, electron donating by resonance through lone pairs. A similar situation applies to the nitroso group, N is equal to O. Analysis of each option. A. N is equal to O, nitroso group. This group is electron withdrawing overall, deactivating the ring, but it possesses lone pairs on nitrogen that can donate electron density into the ring via resonance, specifically stabilizing ortho and para positions. Thus it is deactivating but ortho-para directing. B. OCH3, methoxy group. This group donates electrons into the ring via resonance, lone pairs on oxygen, making it an activating and ortho-para directing group. It is not deactivating. C. COCH3, acetyl group. This carbonyl group withdraws electrons from the ring via resonance, making it deactivating and meta-directing. It does not direct ortho-para. D. NO2, nitro group. This group strongly withdraws electrons from the ring via both resonance and induction, making it deactivating and meta-directing. It does not direct ortho-para. Therefore, only N is equal to O, option A, fits the description of being deactivating but ortho-para directing, analogous to halogens in behavior. Therefore, the correct answer is A. Therefore, the correct answer is option A.